Hey everybody, this is Smitty, and I've got audio this time. Uh, this is Smitty working on something. Today I'm going to be doing part 3 of the Learn to Solder kit that I've been working on the last couple of nights. As you can tell, today is during the day because I've got a bright sunny window behind me. Sorry, so I'm going to be backlit, which is going to be weird, but if I do that, then it changes anyway. Oh, hey. Is that trying to remember the handle? Something 405th. What's the part before it? You're muted, by the way. And you've got no audio. Either that or I've got no audio. Let me try turning that up. Try again. Nope, still got nothing. Why? Check 1, 2. You would think that this would be easier, but it's not. Anyway, so I'm going to be working on the part 3 of the Learn to Solder kit that I've been working on the last couple of nights. So the first day we got the schematic all done and we chose physical layout or physical components. Then yesterday we worked on putting components in the right spot on the board, but I didn't actually connect up any traces. You don't really want to do the traces until you have all the components in the right spot, because otherwise you're going to be deleting a lot of traces and moving them around. They don't really move cleanly after you move a component around. You kind of want to set the component first and then lay the traces down. So we did all the component placement yesterday, and then I'm going to try and lay down some traces today. So yeah, let's go ahead and get started. I'm going to move that over there, and let's share that screen and do that. Really quickly, I'm going to make sure my sound's going to the right spot because I could not hear. Was it Tanker 405th? Did I get that right? Yep, there he is. Tanker 405th. I just wanted to go look at Twitter. So he's the guy who was helping me out last night. So that'll be cool. Test my sound. Yep, audio's going to the right place. Okay. So I think we got everything in the spot where we want it. We got 2 mounting holes, 1 on either side, so that we can have a lanyard with a linear lanyard instead of a loop lanyard, with 2 clips instead of just the 1 clip. That keeps the badge from spinning around as you're walking around. It makes it stay facing out on your chest, which is kind of nice. We got the 2 multicolored LEDs up here. They're the WS2812s, which are the individually addressable LEDs that you see on like the big RGB LED strips. We got 1 pin coming up from there. In fact, I'm probably going to change that to either D8 or D9 so that it has to travel less, just from here to there instead of all the way down here, which would be kind of cool. And data out from the chip into 1 LED, out of that LED into the other LED, out of that LED into this header over here that we're going to make available. So if whoever picks up this kit wants to play with LEDs, longer strips of LEDs, they can just hook up right there, and then these will be the first 2, and then the rest of the strip will hang off over here, which is kind of neat. ICSP header so that you can program the chip, take it by the brainstem and program it. Then an FTDI header, which will get you access to the D0 and D1 transmit and receive, the standard UART that's built into the chips. But once you get a bootloader on it, an Arduino bootloader, you'll also be able to program it through this serial header with an FTDI serial cable, just as you would if it were like an Arduino Uno or something like that. In fact, this will look very much like an Arduino Uno when it's done. A couple of DC bypass caps here on either side of the chip. I got a crystal resonator right here, 16 megahertz crystal resonator. A couple of diodes, one coming from the power on both of these headers. The ICSP has a power pin and the FTDI has a power pin. So those both get tied together and go in through one of the diodes to the VCC line. And then the battery comes in through the other diode. And that way, if you power it through the ICSP or the FTDI, it's not going to try and backfeed your battery. So that's just a safety precaution. A big-ass 100 microfarad capacitor right here that is going to be close to your WS2812 header, because these things tend to draw a lot of power and they tend to be very noisy on the power. So putting a big capacitor right next to that will hopefully keep that noise from getting back into the microcontroller. Got a couple of resistors down here. One of them is just a pull-up for the reset line, and the other one is the series resistor for that diode, and that is, or for that LED. That LED is an infrared LED. So we'll be able to transmit infrared data, and then this is an infrared receiver, 38 kilohertz demodulated receiver. And this box right here is a box that I'm using as a component keep out, because hopefully I want the builder, since that LED is going to be pointing straight out of the board, I want the receiver to also be pointing straight out of the board, but they're meant for right angle mounting, so you kind of have to lean it back so that it'll mount flush against the board, and that's what that's doing there. There's another little a bypass cap or decoupling cap for the receiver, because if I remember correctly, the receiver is kind of susceptible to noise. And then over here we have an I2C bus header and a 8-pin SOIC surface mount socket, or not a socket, but a little spot there for either serial attached EEPROM, or what I really want it for is a ATECC 508A, which is a little crypto chip that Atmel makes that does elliptic curve cryptography and hardware. It has a little hardware random number generator and some other really cool stuff, secure key storage, all kinds of neat things. But it's the same pinout as the serially attached EEPROM. So I can put one set of pads there, and it will work for either chip, whichever anybody wants to use with it. I'm not going to be including it in the kit, but if people want to add it after the fact, they can. I don't want to make this board any shorter because I want those mounting holes to be clearly above the battery pack, but this purple outline is a battery pack on the back of the board. And I don't want the board to be any shorter than the battery pack. So the board, that's about as short as I can make it top to bottom. And I can't make it any shorter side to side because those mounting holes and those LEDs, that's about as tight as I can get them. The LEDs that I'm using are actually 8 millimeters. These are 5 millimeter components, but they're actually 8 millimeters wide. So I need to give them another couple of, about another 100 mils on either side. It's a little less than 100 mils. Anyway, about some more space on either side. And so that's about as close as I can get all of these components up here. So side to side, that's as good as I can get. So that is as small as I can make this board. And I think all of these components are laid out pretty cleanly. One thing to note is that we have, if you look at these little crosshash right here, what that is it's actually a power plane. So I've laid, I'll turn off the back and you can look at the front. So this is, this big red rectangle here is just solid copper. This is the front copper layer. So this one is my VCC. You'll note, like right here, it's got a thermal tie to the VCC lines of these LEDs. Similarly, down here on the microcontroller, it's tied to the VCC. If I turn off the front copper and turn on the back copper layer, you'll note that the back copper, the green layer, is doing the same thing for ground. What this does is it cleans up all like RF noise. There's copper or ground planes are good at noise reduction of various things. You know, the wires act as little tiny antennas. It's not that big of a deal on a board this size, but as you do a larger board design with longer wires, longer traces, you end up having to worry about noise collection on those long traces. And by putting ground planes and power planes and then putting good decoupling between the power and ground, like these decoupling caps here, that will clean up a lot of that noise. The reason I'm doing it here is because I'm lazy and I really do not like having to run power lines all over the place, either power or ground, VCC or ground. So by putting a ground plane on one side and a power plane on the other side, I don't have to worry about it. It's all done. It's there. All I have to worry about routing are the traces, the signal traces, and it just makes things a lot easier. So that's what I'm doing. But the first thing I think I'm going to do is D4 right there gets sent up to this LED, but I don't think I want use D4. I think I want to use either D8 or D9. So, because that's just, you know, less that you have to go across, because I've got a bunch of signals that are trying to cross here, and the more signals you have crossing, then, you know, you have to get funky with the trace routing. D8 or D9 would be a heck of a lot closer to that, and they're functionally equivalent. So I'm going to do that. show you back to me. Hello. And bring up the schematic. And let's start sharing the schematic. Okay. So there are my LEDs. And right now I've just arbitrarily chose D4, but I think I'm actually going to go choose D8 or D9. They're up here. D8 does not look like it has a pulse width modulation, but D9 does. So the OC1A is the output compare register for, or the output compare output, which compares against timer 1's register, and it's the first of the two OCs, the output comparators. And that's what's used for pulse width modulation. So if anybody wanted to get funky with some LEDs, that's how they would do it. So I don't want to use that pin if I can avoid it, because I don't need a pulse width modulator to run these LEDs. So I think I'm just going to grab D8 instead, because D8 doesn't look like it's doubling for anything else that we care about. So edit that one. I'm going to change that to a D8 and done. Save, generate netlist, generate, save. All right. And come back over here and share that again. Let's load a netlist. And yes, I want to change all of those changes. And look at that. So now D8, it's a much shorter line. It goes from D8 straight up to that LED. So let's lay down some copper. I'm going to turn off the back layer just so I only have one layer. Actually, oh, shoot. Okay, I'm going to show my fill planes as hashes. You can see the hash mark up there now, so that I'm not having to deal with that. Okay, so that's my trace tool, and let's do that. Okay, I just laid a trace down. And that one to there. And then well, look at that. Okay. LED traces are done because everything else is VCC and ground, which is going to get taken care of by the planes. So I don't have to worry about it. Put that a little closer. Okay. All right. So I do have to get power from there to there. I'm going to put that on the bottom layer. And oh, I'm going to set some design rules. And this is unfortunately something I don't think Google Hangouts will show you. No. Yeah, this is, unfortunately, this is a limitation of Google Hangouts. I want to show, it popped up a little modal dialogue here that I want to be able to show you, but it doesn't give it as an option. What I'm doing is I'm creating a new class of net, and I'm going to call it power. And I'm going to say that the power class uses thicker traces. By default, the track width is 0.0098, blah, blah, blah. So basically 0.01. I'm going to make it 0.025. And the via diameter is 0.023. I'm going to make that, call it roughly double. I'm going to call it 0.05. Via drill is a 0.015. Let's make that a 0.03. So basically, I'm just going to double all the sizes for roughly double all the sizes for the power lines. They're really the only one I'm going to have to worry about, I think, is the +5, because everything else is a power plane, which doesn't really, yeah, which I'm not actually going to be routing anything. So I'm going to add ground to the power class. I'm going to go ahead and add a ref to the power class, even though we're not moving it very far. I'm going to add VCC to the power class, VIN to the power class, which is the important one. Okay. Yeah, and that's them all. Okay. So select OK on that one. All right. So now I'm back and I'm going to be drawing on the bottom copper layer, and I'm going to do a trace from here. Y. Oh, whoops. Okay. I've got one more that I need to add to the design rule here. What is that? Net BT1-pad1. Okay. So let me add that net. BT1. Add that to the power class. BT1 pad 1. Yep, that's correct. Okay. All right, now let's try this. There we go. That's much thicker. And I am on the green layer, so it's okay for me to cross that red trace there. Green is the bottom, red is the top. I'm hesitating because I've just disconnected that ground pin. So that ground pin is now not going to have a direct connection to that, but it can go right. It'll be fine. It'll be fine, to quote my DM. Okay. So I want to go back up to the top copper layer, and I'm just going to connect all of these pins. Ooh, hey, that's a big fat one, isn't it? So is that one. So is that one. That's okay. And then out to the crystal. Crystal. Okay. And big fat ground. You know what? Whoop. I am going to go ahead and make big fat traces to these and not just rely on the ground plane, because the ground plane does weird things with thermals. And I want to make darn sure that these have, wait, oh, that's a ref, haha, just kidding, those. And I want to make sure it has nice, good, solid, low impedance paths. Oh, hey. No, let's go out this way. Like that. You know, since we're there. Reset. Okay. Hit it around. Look what that does. That makes those lines straighter. And then I need to get 85. And then 84. Yeah, sure. That's fine. All right. And that's it. Because VCC. Wait a minute. Why? That is. Got it. Got to rerun the DRC. It only fills out the ground plane when you run a design rules check, and I never understood exactly. Oops, I didn't have to do it again. I don't know why it does that. It is an intriguing thing, but in any case, that would explain why it was saying that the ground was disconnected. Why is it still saying ground is disconnected? Oh, haha, because ground's on the bottom, and this is a surface mount chip. So we have ways of dealing with that. Ground. Let's do what? No. Lay me a trace. Place via. There we go. So now that pin is tied to ground because I just stuck a via right there. Okay. So let's take a look at this. We got the chip wired up to its headers. We got the deep coupling caps. We got the crystal. We still need to get that power done. So let's take a look at the power. You know what? For the same reason, though, I'm going to run. I think I would rather put this trace on the bottom. Nope. That's not what I want. And then move track, create track, duplicate, flip. Is there a nope? Select working layer. Move it up to the topper track. That did not work nearly as well as I'd hoped. Okay, we'll just do it that way. All right, so I'm going to put that LED on the bottom layer then. Wait, no, come on. Knock it off. And then that over there. Okay. And then we're going to put these big power, that layer. We're going to put these big power traces on the top layer. Oop. Okay. That seems silly. Hold on. What are you going to do with that plane when I do that? Yeah. All right. Never mind. I take it back. I don't want to do that. Okay. Especially not with ground, because all that did was cut up the VCC plane. Sometimes the thermals connecting the plane to the pad can be awfully small, and by running your own pads like these, you can make them a little less anemic. Like, what are we doing here? So that ground, all that's doing is chopping up my VCC plane. Like, okay, so the example I'm talking about is that trace right there. That little bit of copper right there is a little bit narrower than that bit of copper right there because I told the trace width to be kind of high on the VCC stuff. So the trace I made is a little bit thicker than that, although I guess it doesn't really matter. All right. Trust in the copper plane. Turn off that. Then delete that. Delete the track. Delete that one. Track. Okay. Trust in the copper plane. Track. And then run a DRC. So it'll recalculate the plane. All right. So that looks reasonable. Those are good thermals, I guess. And then the copper plane, the bottom plane, looks very similar. Yeah, all right. I'll allow it. Okay, so what else are we doing? Um, well, we need to get D0 and D1 all the way over there. We can do that. We're going to do this on the top layer, I guess, for now. Hmm. Hey. I also got to get reset to the there's no reset's got to go all the way up there. Huh. Okay. Do I go bottom layer on this or do I do that? That looks reasonable. We got to get RTS over there. I think there may be a VIA involved in this one. Oh, you gonna let me do that? I don't like that. Okay, that's better. Still not comfy making though. All right. Okay. And then, oops. Let's connect that one up to there. And we got to get D2 all the way up there. I think we're looking at a bottom layer here. Okay. Why are those resets not? Why does the rat's nest need think those two need to get connected? What am I doing? Why? No. I should not have needed to do that. I don't know why I thought I needed to do that. All right, so can I run vin on the outside, or is that going to be too close to the edge? Okay. So where are my VCCs? Because I'm running a bunch of stuff on the top layer. I don't need that. I don't need that. I got a VCC there. And that one's got to go all the way around through here. Here. Let's do it like this. Run a DRC and turn on the planes and turn off the bottom layer. So that's my VCC plane. Power is going to come in from either of those two spots. It's going to go all the way around here and over in here to get to, well, reset's not going to take much. That's a 10K, so that's plenty. That's even going to be plenty, especially since I've got a decouple right there. That's going to be all the way around like that. Yeah, that'll be fine. I might consider trying to run those lines this side, just so that I'm not disconnecting my VCC plane from the rest of it over here. I mean, we're splitting hairs here. This will be much better than a single trace for any of this, but still. Up here, so power's going to come in here. That's my source. It's got to go up there. It's got a strong decouple there, and that strong decouple will be plenty for those. Okay, what does my ground plane look like? I got a strong ground right through here. There's a ground source. Yeah, that's plenty. That's all good. That's all strongly decoupled. We're fine. These have good strong grounds. That all has, that's a good strong, yeah. Okay, so our planes are okay. Sometimes when you're running a whole bunch of traces, like this spot right here, this effectively disconnects the ground plane down here from the ground plane on the other side of the trace. And sometimes you have to pay attention to that. You want to make sure that your planes, or in this case, it's a VCC plane, but you have to make sure that your planes are have good connections, that you don't ever accidentally completely disconnect one, right? The only connections between the top half and the bottom half here is that little channel right there, and then a little bit over here. This side right there is another connection between the top and the bottom. Whoa, oh, that's not what I wanted. So all of this area over here is connected by that channel and around here through that channel to get to the VCC on the top. And if I were doing RF, I would be worried about that, but this is a low frequency digital signal, and that's plenty. I mean, the alternative is to run a trace that is, only that wide, right? Because that's where my power is coming from here, from the battery, and then from my serial lines coming in over there. So I'm going from a trace that wide to a trace that wide. And so, yeah, we'll be fine. This will totally be fine. All right. So I've got 3 more lines to run, it looks like. Unfortunately, I can't choose closer ones for these because these are hard-coded SPI. And what's worse is that I'm about ready to cut that in half again, like I was just telling you about, because I got to run a trace from all the way from over here to all the way over there. Well, poo. That is going to completely disconnect that VCC source, because that's where power comes into the plane. It's going to disconnect it from the top half. The only connection will be over here on the side. So I think what I'm going to do is I'm going to end up splitting these traces in half. I'm going to run it on the top layer for half of the line and the bottom layer for the other half of the line. There's less ground over here, so I think I'm going to use the bottom layer to get through the chip. And then I'll use the top layer to get across. Okay. So that one needs to go. Oh. Stand by. There we go. Now I can see. Up. Stand by. Now, really. Come on. Oh, for the sake of Pete. Knock this crap off. Okay. So there we go. I'm going to go across like that. and go halfway here, and then place a via and continue the rest of the way up. And of course, I've got the top layer turned off, so dang it. Oh, shut it, cat. Okay. Let's try this again. We'll go halfway across here. Place a via. Okay. Oops. Go back to the bottom layer. Oh, I can't get through there. Yes, I can. All right. Now let's try this again. Place a via and go straight into there. And then for this one, go ahead and use this opportunity to get across to the other side. Place a via there. All right. Run a DRC. DRC is design rule check for anyone who may not know. And let's take a look at our copper planes. And I'm going to look at the top plane only. So what kind of horrible things have I done for my top plane? That's where my power source is. I got good power over here. All of that stuff is going to be fine. We've already determined that that stuff over here is going to be okay. But I have that path to get up there or that path to get up there. I might be able to move these traces down a little bit to give that path a wider, make that path right there a little bit bigger because it's got to go through that. Yeah. All right, let's take a look at the copper and see what doing, or the bottom layer. So I got a ground there, but that's otherwise a pretty solid. Dang it. This is not easy. I don't know. What do you think, Tanker? Do you have any magic suggestions, or have you stepped away? Hearing none, sounds like he stepped away. That's cool. See if I can move this around a little bit. Nope, there you are.
Yeah, I caught the last part of that. Well, we got a broken plane.
Not broken, but it is definitely a it is definitely a very narrow point in the plane.
Where was it again? I was just getting
right
back
here.
to the screen.
Right here. So let me turn off the bottom copper layer. So this is the top copper layer. It's very narrow right there and around here. So this is where our power comes into the plane from the two diodes, right?
Right.
And so the power from here has got to get through that narrow thing there, all the way around here, up there like that, up to the decoupling cap and the LEDs. And that's probably fine. I'm probably splitting hairs here.
Yeah, what kind of current is it going to be pulling?
Well, those LEDs might potentially be pulling a fair bit of current, but they're not going to be pulling it from the... Yeah, I'm splitting hairs.
Yeah, I honestly think it will be fine.
It'll be fine. You sound like my DM. I'm sure it'll be fine.
I mean, do you plan on pulling more than about 500 milliamp?
Hopefully not.
Then it should be fine.
Okay. I do want to move this one down a little bit. Unfortunately, I may need to just redraw the entire trace because
Probably be easier.
that's another thing that KiCad does not do very well is let you edit a trace. Once a trace has been plopped down, I can't like add a joint to a trace or anything.
Mm.
Which is kind of a bummer. All right, so I'm going to delete that one. Track. Okay. So I am, however, going to, let's see, we're going to start on the top layer. Yeah, we're going to start on the top layer. And I'm going to turn those off.
Now, what if you move both of the shot keys up just a little bit?
Oh, that's a damn fine idea. You are blipping out, by the way.
How about now?
Sure. Hey, nope. How about I? Dadgummit. Drag footprint D0 up like that. And drag footprint. See, this is why I like having other people watching me work. Because you guys keep me honest. And show me the simple solutions to the stupid crap I do.
It never hurts to have a second pair of eyes.
No, it really doesn't. Okay. So now we're going from here. Still got that little narrow area, but that's a much better area. Look at the bottom copper. Oh, that's solid. You know what? I'm going to move these vias over a little bit because we got solid over here. I want to give, if I move those vias, I'll be able to take a little bit better advantage for the VCC plane. Okay. I wish there was a way to get it to redraw the plane short of doing a full DRC, but let's see here. Okay, what does that do? Nope, that's worse because that's bad up here. What does that do to ground, though? No, ground is still in good shape. Okay. Oh, phooey.
Ooh. I was going to say maybe in between the top of the leads for the shot keys, but I'm not sure what you got on the other side there. I think it won't go. Actually, top side.
Top slide on the bottom layer. So route it all up here. That will cut off ground for the top half.
Gotcha.
Ground will have to go all the way around here. Which is why I'm doing the vias, so that I'm cutting off half of ground's path and half of VCC's path.
Now, what if you move that top via?
This one?
If you routed it between the leads at the top of the shot keys, is that possible?
Certainly.
I'm just wondering if that would give you a little better clearance there.
What's that going to do to my ground? So if I bring it up to there, I'll have to go all the way to there. So it'll completely cut off this path here. I mean, that'll be worse than what I've got right now because it will completely cut this part off. Whereas right now I've at least got that little bit there.
Yeah, I see what you're saying.
What I want to do is here. Okay. Let's try it. Stand by. One moment, please. And go to that. And do.
Should I play some elevator music?
Do, 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 do. Oh, that's going to undo the whole thing, isn't it? Yep. Okay. What? No. There we go. All right, so I am starting on the front copper. So we're gonna go here, go across there, there, like that. I think that's about where I want it to be. Okay, so I can move this down here now. In fact, I could probably even do it right there. Oops. And damn it, I need to add another corner there. Urgh. Seriously, KiCad. Why can't I add a corner to a via? Is there not a way to do that? Because what I want to do is move that there. Track. Track segments, keep slow, begin track. Move track, create a track array. Break track. Select working layer, change segments with. I think I want break track maybe? Yoink. Oh. Cha-ching! Okay. We'll just do that. All right. So, DRC. Do that. Show me my ground planes. What do those look like? All right. So there's my top plane. Plenty of power space. Okay, that makes me happy. I'm happy with that. Let's look at the bottom plane. Ground, plenty of power. Okay, I think we got a solution. That's it. Are we done?
Looks good so far. And why are you still getting the errors on the LEDs?
I think it's because the pins are too close to each other. The pins have a keep out range, and I think they are overlapping each other's keep out range. But there's nothing we can do about that.
Yeah. Just solder carefully.
Exactly. But I think we're done. Does that look right?
It does.
Oh, well, okay. Except for the words. I need to put some text on there because that all sucks. But I can fix that.
Now, is that a V you have for the ground of that SMC in the bottom?
That one down there?
Yeah.
Yeah.
Okay.
That'll that ties it to the bottom plane.
Yeah.
Do I want to throw a surface mount decouple cap on the bottom of that?
Yeah, you don't have any components on the bottom so far, right?
Just the battery pack. Oh, the battery pack's going to be covering that up, so no, I can't.
Yeah.
Unless I stick like a little 1206 or an 805 over right here next to the battery pack.
fixing to say it had to be next to the battery pack because on the front you really don't want it that close to those pins.
No. Okay.
You don't hear any background on my end, do you?
No, not right now.
Okay. Both kids are awake and wide open.
Yeah, my girl is out playing at a friend's house, and my wife is napping somewhere, napping in the bedroom.
It's almost bedtime here.
Oop, oop, oop. You guys running into any issues with snow?
We had maybe 1/10 of an inch.
So, no.
No.
There we go.
Now, the northern part of the state, some of the higher elevations got a foot, but not here.
Yeah. I'm just staring at this, waiting for something to pop out at me as I don't like this, and I'm not finding anything.
Scary, isn't it?
It is. The only possible thing that I might want to change is this. That's the only thing that's screaming out at me as I don't like it. And instead take the reset line from here and... Oh, nope, I've already got a green going down there. Already got a bottom layer trace going that direction, so never mind. I was thinking maybe go bottom layer across and then up. But I can't, because it would cross that one right there.
And that one's got to be on the bottom so that the case they are transmitter doesn't hit it.
Oh, sure. I was going with it on the bottom because it's going perpendicular to the other traces there, right? Normally,
Yeah.
on a large circuit board, you would have all the horizontal traces on one side and all the vertical traces on the other, right? Well,
Right.
these happen to be angled, but otherwise a similar philosophy.
Gotcha.
Yeah. Now just for the words. Let's go put some silk screens on this. Render text front, but that's not silkscreen text, I don't think. Is it? Are those silkscreen? Nope, that's not silkscreen text. So I want the silk screens to be on there. Not adhesive, not a paste. It's not masking. Drawings, comments. Yeah, don't care about that. Eco 1, Eco 2. Don't even know what those are. That's the border, margin, blah, 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 blah. Okay, yeah. So render, get rid of the text because I don't want those. I'm going to lay out my own. Okay. All right. Let's see here. Text. I don't like putting D1, D2, R1, R2, and then making people have a mapping of component names to component values. I prefer just to put, oops, wrong layer. I prefer to put the component values straight on the board. We do 0.4, 0.4, and we'll do another one. 0.01. And then let's copy that to a couple of places. Right there. Where else? Copy that up to there. And copy that over to there. All right. That one is a 470 ohm. 470. Oh. Four, okay. Sure, and rotate that. Put that one there, and I'm just going to go ahead and copy these so I don't have to keep changing the text size, but I am going to have to change the value. How about the edit? That one to be 10K. That's it. 10K. Top of a via. Okay. Copy. Edit. We got 16 hertz. Actually, up to there. Whoop, what? I don't know if I can put text that close to the edge of the board. Okay. Edit. Edit. Oh, which one's clock? Which one's? I don't remember. Okay. Schematic. I've got a schematic around here somewhere. There it is. SDA 5 is SCL. I'm sorry, 85 is SCL. Okay. 85 is clock. Okay, so edit. Clock and edit. Make data. Right. Visible enough? Ground, volt, data, and clock.
Now for clock, maybe C lowercase k, so I don't think common.
SCL. K like that. Here on I squared C, they call it SCL, right?
Yes, I believe so.
Oh, shoot. Edit. Display style, no more justification, left.
Yeah, SCO.
Man, that is really hard to read, isn't it?
Yeah.
You know what? Hold on. Thickness 0.1. Can you do 0.05? What does that look like? Left justified 0.05 and make that DA. Easier to read?
I can read them. Isn't the trace going to run right through the middle of them, though?
Trace I'm not worried about because that's going to be underneath the solder mask, and this is all on the silk screen on the top layer.
Okay.
I'm not worried about the trace. Edit, make that a 5 plus B plus. We'll do V plus. Oh, and make that left justified. Go there and move it like that. All right. Edit G and bad that breaks. Justified. Go move it there. Oh yeah, the D is completely lost. Okay. Whoop. A cancel. Edit that. Get rid of the D. Okay. So CLDA V plus GN. I kind of want that I squared C to be bigger. All right. Copy that to here. Edit. PX. And copy it to here. Edit. RX. So that doesn't get confusing. All right. Copy that over to here, but rotate it. And edit. There, because I'm going to be labeling these pins as well. Copy. Okay, so that's ground. Edit. Plus. Edit. What is it? Hang on. So this is D0. Go back to the schematic. D0 is receive on. D0 is receive on the chip. So it's going to be transmit on PI. What? Transmit. There we go. Edit. RX. Shit. Do I want to label these in terms of the board or in terms of the FTDI header?
That's a tough call.
Is the biggest reasons why I like SPI, because it is completely unambiguous about that. Mm-hmm.
Personally, I kind of like it like that.
So that tells you plug in the FTDI, receive here, plug in the FTDI, transmit here. The other option is I can talk about pin colors. Okay, so let me clarify what it is that I'm trying to address here. So I don't have any of the 6-pin FTDI cables, one where it's a single 6-pin connector. I have the ones where it's 4 individual wires like that, so that it's much more configurable. You can plug whichever one into whichever pin you need. You still have the ground, power, transmit, and receive, although this one does not have DTR, so I would not be, or RTS, so it is not able to reset the chip. So maybe what I should do is I should just label them with colors instead of labels. I kind of like that idea.
That would be a lot more foolproof.
Yeah. Okay. Edit. Right, justifying these while I'm at it. So. And then I have to remember green is go, if I remember correctly. Okay, so green is the transmit from the FTDI. So that one goes here. So GRN. That there. Edit. T. You haven't actually been seeing what I've been doing there. Sorry about that. So FTDI serial pinout, but I want to know what colors the full 6-pin cable uses, because I think they're different.
Yeah, I think I just pulled up a 6-pin. It's like greens, reset, yellows receive, orange transmit, reds VCC, black is ground, brown is CTS.
So this is the one I'm looking at. Is that the same one you're looking at? Orange and yellow are the transmit and receive?
Yes.
Or maybe that one there? That's probably a better... Yeah, that's a better diagram. Okay. I'm also kind of tempted to... there we go. I'm tempted to take this connector and move it down a little bit so I can put the word FTDI up here. Because I got some space between the receiver here and the ICSP up here. Kind of want to move this down, although it is going to involve redoing traces, but I think I can handle that. That. Why error tracking your pad? Okay, fine. That's what I'm trying to fix. Jerk off. It's in an error condition because it's too near a pad, but I'm trying to move it away from the pad. I just can't move all 3 of the nodes that I need to move at the same time to get it to do it. Jerky. KiCad, you're really chaffing my hide. Is that going to do it? There we go. That did that. Okay. So we'll drag that. Oh, no. Drag Okay. Okay. So now I can take that, move it up there, rotate it. Right there. Okay. So that is a better labeling of that. Move the black down to there, move the red down to there. But it's only green on my cable. Green and white on my cable. Otherwise, it is not white but yellow. White, yellow. And that goes right over the other pad, so that's not going to work.
WTYL.
Barely. Edit. That slash is awfully wide. Oop. A variable width fonts. What about this one? And what's the orange?
Orange is transmit.
You know what? Double space. Well, let's try that. Up? No, that doesn't make sense either. And then what color is that? It's green. I don't have one on my wire, so I can just make that green. All right. That look. Green, white, yellow, green, orange, red, and black.
Looks good.
Okay. I'm not going to bother labeling pins on the ICSP, but I am going to label it as ICSP. Let me move this up a bit. Oops. Pulls the copy that up to here. Edit. Key. That. Okay. Copy. And edit that. And we'll make that right justified. 12. There. Edit. Oh, copy. Edit. Right justified. Okay. How should I label the diodes, you think?
I normally just see them silk screen as a layout.
Yeah.
Just like that.
There aren't different types of diodes I need to worry about.
True, because those are shotkeys, right?
Those are shotkeys, yeah. And they're just the same, two of the same diode. So as long as the cathode bander gets put in the right place, we're good to go.
Exactly.
All right. So let's grab that one. This right there. Rotate it. There. Edit. AT Mega 328P. Oh, edit. Center that. Move that right there. Is that it?
Well, will the Schottky symbol fit inside the silkscreen casing? Oh, but you got the
I got
vias.
3 vias right there. I think that'll be enough. Famous last words. Huh. All right. I do have one other thing I want to put on here. That's probably the place to put it. Make that less justified. Small power 16. Split that. Don't ask. Actually, right there. No, it's going to get covered up by the LEDs, isn't it? I don't want it there. Yep.
The only place really open is right there where you started, because if you put it in the center, your AtMega will cover it up.
Apparently I moved it instead of copying it. Whoops. That looks good. I'm pretty happy with that. Oh, hold on. I'm not going to bother labeling the ICSP, but I should label the WS2812.
Yeah.
It's 5 volts ish. I'll just do V plus. Data and copy that down to there and edit that. And do, what is that, ground? There we go. What's missing?
Nothing I can think of. I mean, it looks really good.
Oops.
Because the silk screen on that 100 microfarad will show where the positive is. So,
Yeah, I mean, technically it does because the that part is the ground. That part is supposed to be where the negative, the stripe on the electrolytic is.
Yeah.
But that's a good point. I probably should make that a little bit more obvious for newbies who have never done this before. Edit. Center justify that. Let's redraw that. There. Copy it.
Yeah.
Here. Yeah. Edit that. Hey, rock off.
As far as that goes, should you do the same thing for the LEDs?
So the LEDs are a little bit more obvious because they've got, or this one here has got the big flat spot there.
Yeah. Talking about the 2812s at the top.
Yeah, that's a good question. They technically also have the little flat spot on it. Let me go grab one. Stand by. I'll be right back.
Okay.
Where are those? Those are the flickers. Where are my LEDs? Crap. Those aren't them. Stand by. I'm hoping they're in the other room.
No problem.
Found them. Okay. So there is a big flat side on these as well. Let me make sure the big flat side is in the right spot. So that's the LED. Looks just like a normal LED, except that it's got 4 pins on it.
Yeah, for RGB and data.
Except that it's not RGB and data. It's
Oh yeah, it's
not on these.
12.
So, assuming I got the pin out right, there are different length pins.
Yeah.
And that long one is the square pad because so there's the flat edge. There's the long pin, the second one from this side over here. And if I go back to that, there's the flat side, and the second one is the square pad there, and that's the one that takes the long lead. So assuming I got the pin out right here, that it is in fact data in, VCC, ground, and data out in that order, then this should be good. The square pad will be the long wire. Let me go. Here's where I bought these. I'll probably have to buy a whole bunch more. Damn it, purchase history.
Yeah, data in, 5 volt, ground, data out.
You looking at my purchase history?
Oh no.
Like that was a little disturbing.
I tend to think out loud, so.
Oh. What are those? Global dip LED, but
Now the ones you have, are they like the diffused neopixels?
these are not NeoPixel brand. These are cheap eBay brand.
Gotcha.
So,
Henceforth to
that's,
like the neopixel.
yeah, I think so. Be perfectly honest with you, I have not actually plugged one of these into a breadboard and played with it yet, so I don't know for sure. Having to go back pretty far in my memory as to when I bought these. Don't believe it was this far back. I've got a long purchase history on eBay. It's kind of depressing, actually. Yeah, so if you're interested in getting into electronics, one thing I recommend is buying in bulk for a lot of the common things. I have had, there it is. I've had part good luck and part bad luck with some of the stuff that I've bought in bulk on eBay. Some of the stuff I buy in bulk on eBay has been really good. Some of it's been absolute crap. So buyer beware. But these are the LEDs that I have in my hand. And shoot. That shows the long pin as pin 3. So these might be backwards. That's unfortunate. It's just a matter of going in and redoing some components, but kind of like what I had to do for the IR receiver. Are you reading that the same way I am? The long wire, I don't know how well it's resolving for you.
Yeah, 3 is ground.
Here, let me do this, which will hopefully get Google to zoom in on it a little bit better.
Yeah, see, digital in, 5 volt, ground, and digital out.
Yeah, but the long lead is pin 3, which is ground.
Yeah.
Whereas on this one, the long lead is VC. So I've got my pin out backwards. Okay. I got some changes I need to make on a schematic. They're down here. Okay. I need to change the component. Damn it. All right. Tools, library editor. Gonna load a library, actually. Change my screen share.
Looks
Because
like that's the way the. Oh, sorry.
No, go ahead.
Looks like that's the way the NeoPixel brand are laid out as well.
Okay. So this will make it more standard, quote unquote. WS 2812. Okay. So there's my component. And I just need to change these pin numbers. Edit, make that 4. Edit. Edit. And 2. Wait.
Ground is 3.
Yeah.
Data ends 1.
What the hell? Hold on.
It was right.
Hold your horses. 1 is data in, 2 is VDD,
3 is
3 is
ground.
ground, force data. Oh, no, that was the problem. Okay, hold on. All right, I'm going to do this differently. Control Z, 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 Z. Undo all my changes. You know what? I'm just going to throw this away. Save to current library, save and exit. Exit without save. I do not want to do that. What I want to do is I want to change this outline here. Okay. That's it. I am going in and making a proper footprint for this. Footprint library wizards, footprint library manager. I think this is the first time I've tried to do a footprint in KiCad. Oh no, I've had to do other footprints. Where is it? Libraries. Nope. Where is it? Oh, crikey. Footprint editor. There it is. Okay. Knock that shit up. Oh, sorry, I'm trying not to cuss on these. Okay, footprint editor. Let's load a library. Let's load the Smitty library, or the libraries library, which is the Smitty library. And I need to just start over with a brand new footprint. 8, that's 12. Ref down there. Okay. So I am going to drop some pins. It does not talk about spacing, but if the spacing of the other LED is correct, then these are going to be 0.05 inch spaced pads. Okay. These are millimeters. What? No, give me inches. Yeah, we'll do that. All right. Dunk. Wait. Hang on. Breadboard around here somewhere. I want to actually measure these and make sure these are 0.1 spaced. I don't think these are. Oh, yeah, they are. Okay, so they're 0.05 spaced. Okay. So we're going to do one there, one there. Oh, that's unfortunate. Those are going to have to change. What's up, Zoe? You just looking at what I'm doing? Okay, you're allowed. Because I'm streaming right now. Did that freak you out? All right, well, apparently my daughter doesn't want to be on the stream. The camera's off right now. All they're looking at is what's on the screen. No, it is not MM8. It is not like BB8. It is very different. My daughter is very silly. I love her to death. Okay. So I want pin 3 to be a rectangular 0.06 inches. That's not going to work. That's going to need to be smaller than that. 0.04 maybe? And I make that a 3. Nope, wrong way. Or a hole. Oh my goodness. How big of a hole do these need? Do you have some specs on the pin sizes on this?
That's what I've been perusing for. Nothing concrete yet.
Okay. EPA 106. Okay. Unfortunately, I don't know where my calipers are. Otherwise, I'd
Still
just
haven't
measure it.
found them?
No, I haven't.
Actually, you know what I was
Okay. Well, let's make shit up. Good at that. 0.02. It's not going to do it. If I do that one, what did I make those before? I think I'd go 4, circular, and a 0.02. 4, 02, edit, 4, and that 2. And that looks like it would work, but that would also be a major pain in the ass to solder to. So I'm going to go for oval. 6, nope, 4, 6, 5. Okay, that looks better. Make that oval. Make that 6. Make that a 2, 5. That looks pretty good. Rectangular. 4, a 6. That's 2, 5, like that. So that's our square pin for the long one. Make that oval, make that a 6, make that a 2, 5. Okay. That looks pretty good to me. Some math. So let's see here. 8 millimeters, 5.4 divided by, no, 8 over 25.4. That is going to be about 0.314 inches. So since I've only got, all right, I can't do 15 mil spacings, but I can do a 10 mil spacing on the grid and make that a 320. So if I come out here to 3.6, and what? Where's my cursor up there? What the heck? Why? Oh, haha. No, I did. I'm so confused. Okay, so out here to 4, 5, 6. There we go. There's my LED. Does that look about the same size as that? You think? I should probably flatten out one of those sides, shouldn't I? Okay. That's going to be the side closest to the long pin right there. So I'm going to draw a flat line right from there to there. There we go. Does that look good?
All I see is you.
Oh, ha 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 ha. No, that does not look good, is what you're saying. How about that? There we go.
Yeah. I finally found a data sheet, I think.
Oh, you did? Okay.
Took that long to find one that wasn't for SMC.
What does it say about pin size?
It has everything except that.
Of course it does. Well, that's unfortunate. Okay. What does it have for pin spacing?
It doesn't have that either.
So
it's taking
really
this long to find a half-assed data sheet.
All right. Well, I'm going to stick with what I've got. My very scientific measuring method of laying this against a board that is, a proto board suggests that they are in fact 50 mil spaced. So every 2 pins is 100 mils, standard 100 mil spacing. So I used 50 mil spacings here. And then 8 millimeters is 0.315 inches. So I rounded up to 0.32, and that is the size of this circle here, is a 0.32 inch circle centered on the same thing, and then flat line there. So I'm calling it good. Save footprint in active library. WS 2812 8 millimeter. Cha-ching. Okay. So we're going to shrink that. We're going to go back to schematic, but I don't actually want the schematic because what I want is the parts selector. As soon as that comes up. Come on now. You faking it? There we go. And that one. Okay. So that I actually want to go down to my libraries library and select that and that and save that. Then go back up here. And generate a net list, generate, save, and then go back to that one. And I'm going to delete that component. Nope. Delete footprint. I'm going to delete that one, footprint LED, and then I'm going to load the net list, read current net list. Yep. Okay, close. Where, yay. Footprint LED 1. And footprint LED 2. Okay. So, turn off my ground planes. Show me a rat's nest. DRC. Okay. But okay. You're not showing me a rat's nest. Don't know why. Oh, no. Oh, because it landed right on top of the pads that were there before, and the traces are already there, so there is no rat's nest needed. That was convenient. No, so is that right? Does that line up with your reading of the data sheet? Data in, VCC, ground, data out, data in, VCC, ground, data out, and ground is now the longest pin. That looks good to me. Let me start viewing my things here. That is my top copper, which is tied to VCC. Good. That is my bottom copper, which is tied to ground. Good. What am I missing? That's always the question, isn't it? If you're talking, you're on mute, by the way. I just looked over and noticed that your mouth was moving, and I'm like, it's kind of quiet. Is he talking to me or one of the kids?
Nothing to see here. Move along.
Nothing to see here. Move along.
Now the at Mega layout, does it have a dimple that you can add to show where to put pin 1?
You know, I was just looking at that actually. Same thing with the ECC 508. So technically, the pin 1 marker, you'll notice how that square thing goes over there, and it's got that little leg right there.
Yep.
That's your marker. Useful, isn't it?
Yes, very.
Yeah. And similarly on this one, you've got that little leg sticking out over there on pin 1. I was just thinking, how could I add a marker to this?
But for a new person,
I totally agree.
maybe a silk screen dot.
Ooh, dot. Yeah, that would do. Oops, hold on. I don't want an arc. I want a full circle. I want it on the front silk screen. Like that. Oh, knock it off.
Yeah, I was about to say you could just put it inside because you just need to see it to align it up for the initial placement.
I try not to cover things up with components whenever I can, because then when things don't work, you go, crap, what did I do wrong?
Good point.
Right? And not having things covered up makes it easier to figure out what you did wrong. So I think I'm inclined to keep that right there. Copy? No. Thank you. Okay, fine. I will draw another one. You know what? Give me a smaller grid. Does that look better?
Yes. Yeah, make that one a little smaller too.
Yep, that's exactly what I'm doing.
Perfect.
Okay. Actually, you know what I can do? I bet you I could do this. Let me go back to 25 mil grid. Why is it only 45? Can't I do a 90 on that? I actually like that better.
Yeah, so do I. But like you said, the dimple will be covered up once you place the chip.
True. But
So
that's at least more standard.
All right, well, let me let you.
Whoa. What the hell? Ah, no, no. I want to move the battery. Okay. I want to mark those diodes somehow.
Do you think you could fit a shot key in between the top of the case and the eyelets?
The word Schottky?
Yeah, the word shot key across horizontal.
I think I'd rather just go with diode.
Gotcha.
Because the fact that these are Schottky diodes is somewhat irrelevant to the solderer.
Good point.
Um,
Are they going to have a little parts bag?
yeah,
Then all they need to know is there's only 2 diodes, and you put them here.
and they're exactly the same. Yeah. Edit this. Make that thinner. Oh, whoops. Haha. Let's try that again. Oops. So that's not on top of the vias. Diodes. How's that?
Yeah, that's the lesser of all those evils.
I think so. Okay. I'm pretty happy with that. We run a design rule check and make sure it's not going to complain about anything. Nope. Oops, excuse me. List unconnected is empty. Problems and markers is empty. So the DRC seems happy. All of my nets are connected. Oh. Wow. That was lucky. I did not pay attention when I was moving that over. What's that circle for? Do I have a via? What the hell? What in the hell is that? Track. I think that was a leftover via. Yeah. Interesting. A little bit of track or via or something. You know what? I'm going to do this differently. Yeah. Actually, hold on. do that one instead. Ooh, better. SoundCon hardware hacking 2016. Yep, 8. There we go. Can you think of any reason I should not go submit this to OSH Park right now?
Maybe they don't offer it in the color you like.
Are you kidding? I love purple.
Honestly, I mean, if I were going to change anything, I would flip the 0.1 microfarad label, rotate it 90 degrees to the left at that bottom one, but next to the R, yeah. I was going to do anything, that would be the only thing. But
Actually,
that's
hold on.
really splitting hairs.
Oh, no.
Redo.
No, what did I do? It's 45 off. All right. Let's do it this way instead. Put them underneath like they are for all the other ones.
There you go.
All of them are underneath and horizontal. Well, underneath where I can anyway. Yeah. All right. Open up your plot diagram. Where's embedded? Preferences, dimensions, tools. No. Where's plot? You can tell I exported from KiCad for OSH Park so often. Plot. It's in file. Okay. I want to plot front copper, back copper, front silk screen. Do I even have any back silk screen? I don't think I do.
I didn't see any.
But I want back and front mask. And I need edge cuts as well. Oh, again, it's a modal that you can't see. Thank you very little. Plot footprint values. Plot footprint values, no. Footprint references, no. I do not want values or references. Do not tent vias. I want vias tented. Force plotting of invisible values reference, no. Exclude PCB edge layer from other layers, sure. Okay. Use proper file name extensions. Sure, I think that's the one I want. Okay. Your screen should look something like this. And in the drills, you should find, okay. So generate drill file. First off, I want inches, suppress leading zeros, postscript, minimal header, absolute. Okay. Drill file, virus.drl, close, and then plot. Okay, and I've got a bunch of files generated there. Okay, so let's go see what this looks like in OSH Park. Get started now, and then go ahead and screen share this. I am already logged in as me. Okay, minimize that. I am going to have to do a little bit of command line hackery here to make a zip file out of this. What are the files that it needs? Zip and into first zip I'll add virus.url, virus-f star, virus-p star, and virus-edge cuts. Okay, so that'll get all my front layers, my back layers, my edge cuts, and my drill file. I'll have a virus.zip. Okay, select a file on my computer. Projects, zoncon, virus, virus.zip. Zoncon 2016. Hacking village. LTS. Learn to solder. Oh my goodness, 28 files in the processing queue. That might explain why it takes so long sometimes. We'll get a better view with the next one. It's fabricated from the top. Look at that. Diodes. 16 megahertz, 0.1, 0.1, 0.1. IR receiver. What's that K doing there?
I don't remember adding a K there.
There isn't one. There's nothing right there.
Nope.
What the heck? Well, that's interesting. But these are visible. GN, V plus, DA, CL, or I squared C. Anybody who knows what I squared C is should be able to recognize those at least. Board designed by Smitty, Merck Smith at, which is good. Zoncon HHV 2016. And then on the back, there's nothing except the outline for the batteries. Bunch of drills, board outline, solder mask, bottom silk screen, copper layer, top copper layer, bottom copper layer. Yeah, all those grounds have nice, good, solid paths to each other, so I'm happy with that. This is the one that scares me a little bit, but again, I think we're okay. We're going to be okay with that because that's going to be right next to its capacitor. That's the important part, right? It's going to get most of its power from that cap if there's any sort of an impedance drop here. But even so, it's going to be better than these. How power's getting into the thing in the first place. So yeah, I think we're in good shape.
The K's still there too.
What the heck? This was very nearly the first time that I would approve a board on the first upload. usually there's a very large iteration process of uploading it to OSH Park, saying, oh crap, I forgot this, or oh, I need to go make that a little bit clearer, or oh, I want to do this instead, or whatever. There's a large iteration process there, but not this time. Except for that damn K. Where's that K coming from? I don't even know what's there. Oh. So I turned on front text, and it's there.
Ah,
But what's it? Why none of the other text is there? What is it? Front silk. What in the hell is that? What is it coming from? Text K. Tell you what, I'll throw it right on top of a pad, and it won't get rendered. It'll get masked out. Is that the only thing we need to change?
that's literally all I saw that was wrong on the OSH Parker renders.
You know what? I want to get fancy. I'm going to try something.
Uh-oh.
I know. Scary, scary. No, I'm not going to do it there. I'm going to try it there. What is that? 2, 3, 4, 5. So 2, 3, 4, 5. So what's that going to do? DRC doesn't complain about it, and it adjusted my copper plane. Good. So I'm going to round off those corners just a little bit. Starting point, end point. Okay, so I want to 4.75 and 4.125 clicks. Oh. Okay. And then we'll edit this one. Starting point 3 and 5, so 3.125. Edit this one. See graphic line 3.125. Okay. 3 to redraw. All right, so I've rounded the corners off of the top of that. Kind of like that. I can't really round the corners down there, can I?
No.
At least not that big. I could probably round them a little smaller, but I don't think I'm going to bother. Okay. And go through the plot, Hoopajou. I do not need to... I didn't actually move any of the components, so I don't need to redo a drill. Right. Start over. Now, select file.
No K. No K.
No K and rounded corners. Come on, big money, no whammies. I totally just dated myself, didn't I? I am of an age.
I am of the age just after your age, so
There's no K, and I got rounded corners. That's good. That's good. What do you think?
I think it looks good. Of course, I've been saying that for an hour, but I think this time it really looks
really
good.
looks good.
Yeah.
Yeah. I'm going to place an order. What is the most exciting part about it's always the most exciting part about doing a project. It's getting to the point where you place an order. 3 of them. So it's, what is it, $5 a square inch when ordering this way. So that means it's 4 square inches. Okay.
Yeah, because it goes down to $1 square inch once you do a medium run.
Yeah. What does that change to the price? Nothing. I don't need the thicker copper. Okay. Excuse me. Yeah. Before too long here. Yeah, that's what I thought. Turn off the screen share on that. That's okay.
I saw nothing.
My information is on plenty of public databases at this point. It's not
As is mine. FCC.
KR6ZY 73s. Everybody, come on down. It'll be a party. Pay with PayPal. Sure. Let's do that. Payment method. Let's change that because PayPal always likes to default to pulling money straight out of your account. And I always like to have PayPal use my credit card instead.
As do I. Need that extra buffer.
Payment method change. One moment, please. Credit card. Use that one. I just like putting everything through my Costco Amex because I get, some percent of cash back on that all the time. Pay now, $20. Now, in 2 weeks, I should have some awesome purple boards showing up at my desk. Purple boards, kind of like that one. Again, it's kind of shiny and it's not really focusing locally. So let me give it something to focus on. That is not working. Why does it not want to focus? Come on. Well, anyway, trust me, that's a pretty purple board. That's another pretty purple board. I just posted about this one recently. It is a breakout board for a ESP 8266. So there are lots of different people who are selling and making these super duper cheap but really powerful boards called ESP 8266. Actually, the little tiny square chip at the top of that one is the chip itself. It is it's like an 80 megahertz 32-bit processor with a whole bunch of flash and a whole bunch of RAM, a lot more than most of the microcontrollers we're used to working on these days. And it has a built-in Wi-Fi stack. So this little squiggly copper track over here is actually the antenna. And it's just, a 2x4, 8-pin component. But it's super powerful. And Arduino, they've made a development package for it so that you can program the chip natively in Arduino. But hooking up to it is kind of a pain in the butt because it doesn't have, the pins aren't spaced to go into a breadboard. So I made a little breakout board for it. And again, you can tell that this is OSH Park purple.
Nice.
All right, so I'm going to put you back on the screen.
Oh, no.
Oh, noes. We're actually going to just let it select based on who's talking at any given time. So that was a project. I kind of, from start to finish, spent the last 3 episodes of this Smitty working on something, which is kind of an arbitrary name that I came up with when, I don't know, randomly while typing, and it's kind of stuck. But I've kind of wanted to show people how the process works, going from I've got an idea and I've got these things that I want to do, to laying out all the components on the schematic diagram, then selecting the physical components that are going to line up with those schematic components, and then laying it out on a board and doing all of the traces and figuring out how to move things so that they trace widths and distances are as short as possible. How to optimize, running traces from here to there so that you minimize your impact on your ground planes and your power planes, and all the different kinds of things that we've had to think about. Mounting holes, rounded corners, making sure that your pinouts are correct, getting it wrong, going back and fixing it, realizing that your components in your library are wrong, going in and editing those so that you fix it and get a working board out of it. That's kind of what we just went through these last 3 episodes has been a very common process. I've done this a lot. I mean, like I said, these are just the ones that happen to be on my desk right now, but I've gone through OSH Park and done lots of little projects like this. And what we just spent the last roughly 6 hours doing is very representative of what that process is like. And so hopefully sharing this with you guys and girls has been useful, has been helpful. Hopefully you've made it this far through the broadcasts, because they are kind of long and not very edited and kind of, I don't know, annoying. For me, I would not watch these videos. I'll be perfectly honest with you. I'm doing it because I like the interaction. And to that end, I want to thank Tanker here for joining us and being my little commentary. Oh, you've got a backdrop now. People can't, I can't see the rest of the family as they're running around now.
Yeah, I hacked that together today, actually. Just a quick PVC frame and a backdrop to block out toddlers running by.
Nice. I need one of those because I've got this crap behind me. I've got all this crap behind me with the windows. I mean, you can see out my horrible backyard and shelves back there with a bunch of stuff on it and random stool. Yeah. So anyway, but yeah, thank you, Tanker 405th. And I noticed you had a picture with a stormtrooper on your Twitter. Are you in a troop?
No, not at the moment. School and work keeps everything trimmed back a lot. We've got the 501st Legion nearby. Just got to find the time to free up to get in with them.
Is the 501st a national organization or like a global organization, or are they just a local org? I've heard of the 501st, and I didn't know where they were, or if it's just a general group that everyone belongs to.
As far as I know, they're at least nationwide, if not global, because everything I see where the troopers are involved is the 501st or some version thereof of them. Okay,
that's cool. All right. Well, I think I'm going to wrap this up because it's about time for me to deal with dinner for the family, and you got work tomorrow, man. You got to get some sleep. What time is it? It's I guess it's only a little bit before 9 o'clock there, so that's not too bad.
Yeah, I get up about 3:30, so I'll be hitting the hay here soon.
Man. All right. Well, I'm going to go ahead and wrap this up then. I've been Smitty. Still am. Will be for a while. Hit me up on Twitter at Smitty Halibut. HALIBUT is my Twitter handle. That's where I hang out. I don't do Facebook. I don't really do G Plus or any of these other things. But apparently now I've got a YouTube channel, so that's kind of cool. Go ahead and hit me up if you have any questions, or if you want to talk about any of the things that we've done here, or just tell me what kind of projects you're working on, because I always love hearing about what other people are working on. Especially if it's something that someone says, you know what, Mark, I was watching your thing and you got me thinking, and I have this other thing over here in my life that kind of needs fixing, and so I went and built this thing to go do this thing and all these things, and if I can fit thing in the sentence anymore, I will. That kind of stuff really fuels me, right? I'm not making any money off of this. There are no ads. I don't want ads. I'm not monetizing on YouTube or anything like that. I'm doing this because I love interacting with folks, and I love hearing what you guys are building. And I would love for you to tell me what you got going. So hit me up on Twitter at Smitty Halibut, and we'll go from there. You have any final parting thoughts?
Well, no. Just I'll try to continue to be the commentator at large and tinker on the side. And if anybody's interested in what little I do, you can find me on Twitter at Tanker405.
405TH. Yeah.
Yep.
Cool. Oh, somebody just joined the call. That is a Japanese character or Chinese character. I can't tell the difference, and I don't know how to read it. Who is that just joined? Somebody who doesn't have working audio. That's fine. That's okay. But we are just wrapping up because I just finished up a lot of the work that I was doing. I just placed an order with OSH Park for some boards that I've been working on. I'm just getting 3 to kind of prototype and test out. I'm going to build these, assemble it, work on some code, make sure everything does what I want it to do. And then if I'm happy with it, after maybe making some modifications, I'm going to place a medium run order and get about 100 of these to make some learn to solder kits for some stuff I'm doing at work. So, oh, hey, what's going on here? Hi! Oh, I want to watch this. This is cool.
What are we watching, Smitty?
I don't know. This is the person who just joined the hangout and is drawing for us.
Oh, hey, yeah, I've got it now.
Those look like Korean words over on the right.
Yes, you are correct.
This is kind of fun.
Ohasagyo.
Eating popcorn, watching us lay out some circuit boards. You don't understand. Okay. Well, we are just saying goodbye. I wish I knew enough Korean to be able to say goodbye. I did 15 years ago. I went on a business trip to Korea once, and I learned hello, goodbye, and a few other things, but I can't remember it now. So thank you for joining us, even though we're just at the end. But yeah. Anyway, this has been the longest goodbye ever, so I'm going to say goodbye now and stop the broadcast. See you all later. Thank you for joining us, and we'll be back next time.